Got to give the people, get the people what they want. I think this one's going to be quick. I'm doing it. I'm trying. 2.5, the fundamental theorem of algebra, and a couple other facts. All right, so first up, the fundamental theorem of algebra says, basically, for any polynomial, the number of zeros / roots / x-intercepts, remember those all mean the same thing, matches the degree of the polynomial. Okay? So, for example, if I have y equals 8x to the 5th plus 3x squared minus 6x minus 15, right? This is a 5th degree polynomial, which means it's going to have 5 zeros, 5 roots, 5 x-intercepts. Example 2, if I have y equals 1/4 x squared minus 7x cubed plus 3. This is a 3rd degree polynomial. Remember, it's the highest degree. This is not in standard form, so it's the highest degree. 3rd degree polynomial, which means that it's going to have 3 x-intercepts, 3 zeros, 3 roots. Okay? Now, another random fact to know is that, if you haven't noticed, imaginary roots always happen in conjugate pairs. There will always be 2 of them, no matter what. So even if you're given one imaginary root, you know that there has to be another one. So for example, if I have a root of I got to have a root of negative I. If I have a root of 3 plus 2i, I have to have a root of 3 minus 2i. And if I have a root of negative 6i, that means I have to have a root of positive 6i. They always happen in conjugate pairs. So, here's the thing that you're going to have to do in class. Find the polynomial with the given roots in standard form. All right? So I'm going to give you some roots. You're going to have to write it in standard form. What I would do if I was you is I would write it in factored form first and then multiply it out. So we'll do this one example together. Let's say you have a polynomial that has roots of 5 and I. Well, first thing you should recognize is that means it really has 3 roots. Has roots of 5, I, and negative I. Okay? That's that thing that we just learned about. So, if these are the roots, if these are the zeros, well then, what are the factors? Why don't you write the factors out now? Cool, you did that because we started this in class on Friday, and you're like, oh yeah, I know how to do this, right? So if this 0 is 5, x equals 5, the root says x minus 5. If this root is I, the factor says x minus 5. The second factor would say x minus I. And the third factor would be x minus negative I, which is just x plus I. Right? So there is my equation, and this is in factored form. But I gotta put this bad boy in standard form. Oh, I could do this. Alright, so let's go ahead and multiply these bad boys right here. So let's do it. Now what I'm gonna do is I'm gonna multiply the factors with the conjugate pairs. I'm gonna do those together because they're gonna work out nice and pretty when I do. So I could look at this and I say, okay, x plus I, x minus I, that's x squared, that is minus 1I x, and this is plus 1I x, and I times negative I is negative I squared. Okay, so let's keep going here. These two, 1ix and negative 1ix, cancel out. So we get x squared, and remember, negative I squared is negative 1, so it's negative 1 because I squared is negative 1. So that's really plus 1. And I should know this is like the sum of squares, right? And so I end up with the sum of squares. So that part equals x squared plus 1. So now I need to take x squared plus 1 times the x minus 5 that we still got to multiply through. So that's easy work. Boom, boom, boom. X squared plus 1, x minus 5, x cubed minus 5x squared, 1x, and negative 5. So I have x cubed minus 5x squared plus 1x minus 5. And I did it. There is a third degree polynomial that has the roots of 5i and negative I. All right, that's it, y'all. Bass, I'm out.